with a commercial project presentation. Thank you, our guests, for coming here to oversee the project and the presentation done by the students. What I have in front of you, I'm just going to go over the agenda for the day. What I have in front of you is a list of the agenda and the name of the students and their teams, as well as the theme for every presentation. So please feel free to look at the names of the students as well as the theme for their presentations. So that's right here. I also have a little sheet, guys, in the front of you. Also has the name of the students as well as the theme. So please feel free to sketch some evaluation here for the presentation that we're seeing today. So that's just going through the stuff. Before I go ahead and start too, I would like to invite my partner for the last 10 years now, Gary, almost 10 years, Gary Ryman, to say a few things for the graduates of June 2012.
Good morning, everyone. Welcome to Dunwoody. Welcome to our presentations for quarter 2 and quarter, the academic year 2012. I always try to have a few words of wisdom up here, and today I'll try to keep it down to a few. But I think we've been going through a period of time where we've had to make a lot of hard decisions over the last couple of years. I know our organization here at Dunwoody has had to make some hard decisions. And I think, we're moving into a year of choices. This is the year of the dragon, and I think we're going to be presented with more choices as we move forward this year. And of course, some of those are kind of obvious. We have political choices that we may all have to make, and we may have other choices in our life that are important to make. So my advice to you is, as you're being presented with some options, and we're looking at a post-recession economy and some post-recession new way of doing things, you may find out that some things are going to change in your normal operating way of doing business. For instance, there's a lot of folks like me that are getting close to retirement, and you might see an exodus of the baby boomers from the job market. We've had shrinking enrollments at Dunwoody, so you're going to see fewer graduates coming through the program. You may find out that the work outlook is a little bit variable, so that you might have a good work outlook for a while, but not be too sure about the future. But generally, things are looking up, and we're all looking forward to a very productive and successful year. This, of course, being the year of the dragon, the water dragon, and so that's really a good omen if you like to look at things like that. So evaluate kind of what your choices might be, and try to make as wise a decision as you can about that stuff. And I'd also like to comment that in this year of the water dragon, I'm going to be a grandpa for the first time. So in June, it's a big event in my life, as children always are. And of course, I can kind of extend that to say that all the graduates are really Chad and I. You are our children going out there in the world. And we want you to stay in contact with us, and we're going to try to look at maybe some other ways of staying in contact with our alumni, and we're very grateful for the supporters of our program who have previously graduated from our design program. They continue to be involved, and we think that's just wonderful. So thank you all. I hope you enjoyed today's presentations, and come shake my hand in the back of the room when you get a chance. Thank you, Chad.
Before we start, I would like our industry guests maybe just to stand up and say one word about their company and who they are. We'll start with my friend Guy here.
Hi, Guy Hurd and Mashad Cooley Erickson. And just a comment that Gary's, we're surviving this recession, and we were 125 people before the recession, down about 106. We're back up to 128, so things aren't all dismal, so hang in there.
Joe Bonella, Hallberg Engineering. Greg Lecker, Mashad Cooley Erickson.
Merkel, Hallberg Engineering. Austin Wagner, Ace Electrical Contractors.
Mark Bell, Eaton Company.
I work with Chad.
Thank you guys, I appreciate it. Our master of ceremony today will be Chris Hashka. Chris is one of our stars here, and he will walk you guys through all the presentations and the theme for each one of these presentations and a few things about the project. But before I move on I would like to thank Nick, and you guys will be thanked a lot today. Nick Verba, and Joe Vomala for leading us all through this 15,000 square foot commercial building with addition. So thank you guys for all your hard work, especially with Revit and all your wisdom that you brought to the project. So thank you a lot. Chris, all yours.
Morning. As Chad mentioned, my name is Chris Hashka. I'm a fifth quarter student, along with the other 9 here. I want to thank the people that took time out of their office days to come and help us out. I realize everybody's working on a pretty short leash these days, and taking that time is, we consider that quite a gift. For a fifth quarter lab project, we designed a functional electrical system for 10,000 square feet with a 5,000 foot expansion. The class is provided with architectural design drawings, design requirements, a project agenda, and an assignment schedule courtesy of Mr. Curdy. Our assignments included producing a Microsoft project schedule, a set of design drawings and schedules that you see posted around the room, load calculations, lighting calculations, locating cut sheets for the various pieces of equipment we selected, PowerPoint presentations, which will be in progress shortly, and a reflective statement at the end of our project binders. Our class of 10 students was divided into 5 teams. Each team completed the entire project, but our presentations have been divided into 5 segments for this purpose. I want to thank Joel and Nick for all the assistance in class time. Revit is very new to many of us, and Nick spent a lot of time with us, very patiently putting up with our questions and helping us get through the Revit portion of the project. We're going to start with an overview of the project by my lab partner, Nick Krenz, and I will be covering load calculations. Nick is currently interning with Michaud Cooley and Erickson.
Chris and I are Team 5, we're your partners. Shocking Design Consultants is our name. So first I'm just going to give a quick overview of all of the electrical sheets that went into our projects. More teams will narrow in on certain aspects. So, title sheet. E2 would be our symbol sheet. E3, which I'll talk more about in a little bit, is our riser. Our site lighting plan. Floor lighting plan. Floor power plan. Floor, the systems floor plan. The low voltage riser. And then Revit also produces, as many of you may know, panel schedules and light fixture schedule imported from Lithonia Visual software, and a lighting control panel schedule. And then E9.1 is the mechanical equipment schedule. And then E10, our details page. Just to narrow in a little bit more on the symbols, it's kind of, symbols seem simple, you know. This was an import from AutoCAD. It's an interesting thing, I think we learned through Revit software, that you can import things from AutoCAD and edit them, and edit the drawing. So we did edit some symbols, such as our light fixtures. There's different type of, the symbols mean different things, such as this would be an exterior fixture, wall mounted, and then a pole mount showing the circle. And then also emergency would be filled, would be represented, filled in. And there's track lighting, and then also there's several systems symbols as well. But the simple stuff is gone now, so let's talk about something a little more serious. For our one-line diagram, just to give you a quick overview, our service entrance conductors coming into the building, we came up with 250 kcm THW conductors buried in 3-inch PVC conduit, schedule 80. Once they come into the ATS, they're terminated, and then downstream of the ATS, we feed the main panel, this time with 3-inch EMT conduit, same 250 kcm, which there are 2 sets, if I didn't mention that. From the main panel, downstream of that, we have our 120 amp receptacle panel and 1.5 inch EMT conduit, and our lighting panel, our 200 amp lighting panel and 2-inch EMT conduit. And also our lighting control panel, shown right there. Just a quick analysis on the automatic transfer switch in the generator. If power were to come out from the utility, so the transformer's gone, the ATS is smart enough to have a sensing mechanism to start the generator, and once the generator comes up to full speed, the ATS will sense that and switch it in approximately 10 seconds. It's an emergency standby generator. The ATS also matches our 500 amp main panel. And with that, I would like to turn it over to Chris, who will talk more about how we came up with the calculations.
For our load calculations, we may have gone just a little bit overboard. I have a lengthy background in process automation, so I found it a little challenging to try and get rid of some of the clerical work that we've anticipated in doing more of these projects. We have used the Microsoft program Excel in order to perform the calculations with some very serious input from Mr. Curdy regarding use of the NEC. We created a load input and assignment tab. This is the ability to take specifications that are delivered in soft copy and edit them slightly and paste them into our program. We then created a load computation tab that takes the data that's input and creates a uniform calculation for sizing things. We then created an NEC summary tab that outlines all the inputs that we have and calculations that we made in a format that you would find used in a standard 220 load calculation. From those 3 pieces, we generate a service entry calculation page and then finally some panel calculations. This is an example of the input tab. You just have to specify the office building type. First section are strictly NEC required values, square footage for receptacle calculations and lighting, show window lighting. From there, we take a look at the spec that we edited, providing a reference of where we got the information from the specification, as well as the various pieces that we are designing our system for. I noticed that a lot of this information comes in various forms and formats, so we created some pull-down lists that after you've entered the quantity of what you have put in, you can put in the value and what the value represents, whether it's volt amps, horsepower, watts, full load amps. So those are all a decision that you can make as you put your data in. We do need to know the voltage that's supplied to this equipment and the type of equipment for our 220 calculations. We have a column to tell us whether it's a non-coincidental load, a continuous decision check, as well as a panel assignment for that particular load. We also need to know whether it is going to use a neutral conductor. And I also have code references for where in the code we are going to take this information and apply it to the NEC summary. Once this has been filled out, the system automatically takes all this information and creates a uniform generation using the various types of inputs quantities we had, and takes a look at the continuous or non-continuous marker and calculates the voltamps required. Based on the voltage input, it also calculates the current required. This is the NEC summary for people that want to see it in this type of format. And we try to get the various categories that we were viewing in order to come up with these calculations. The last output is a automatic piece that looks into finger troubles today. DeWalt handbook for panel rating, and the various codicils within the NEC and the logic that applies to come up with our decisions as we were requested to illustrate those for our project. We get the service entry calculations, and based on the panel assignments, we are given the information we need to size the panels that have been input for our data. Bottom line, after all this work is done, in our particular case, we use the information to size the main panel and to size the generator. These will be covered much further as we move along in the presentation. Next, we have Team 6, Mr. Oladipo Johnson and Dustin Patowski. They will present the power and mechanical details along with our project schedule. Dustin is interning with Dunham.